So now in this video we're going to set the current through an LED with the PNP bipolar junction transistor. We're using the 2N3906 wired as a current source. So current flows in the opposite direction of PNP bipolar junction transistors than NPN bipolar junction transistors. So we have the full supply voltage to the base, the LED is off. When we lower the voltage, when we get to about 0.6 volts lower than the positive supply, you can see that the LED starts lighting up. And as we lower it, the LED gets brighter right there. Main thing though is we are setting the current. So we got the blue LED right there. It drops more voltage than the red LED. We got 0.7 volts there. So when I yank the blue LED and put the red LED, which drops volt less, you would think that the current would go down. But there, as you can see, the current stays the same. So we set the current with the transistor. So now zooming in, I turn the power off so I don't actually accidentally short circuit or something. But in any case, we have here the schematic diagram. The 2N3906. So the emitter is on top there. That's the left pin if you're looking at it from the front. Middle pin is the base, and then bottom or the right pin right there is collector. Hopefully you can see that. And we have the middle pin of the trimpot is the wiper. The other two terminals are going to the supply right there. That's the resistive element there. So hopefully that all makes sense. Now the current though, that goes from emitter down to collector in this case, because remember it's PNP. So we're talking about the more positive part of the circuit, working its way towards more negative when you imagine conventional current. The actual current is set by the resistor right there, but the voltage across it depends on the base voltage right there. As we saw before, you got 5 volts at the base, 5 volts at the emitter. There's no voltage difference. You have to lower about 0.6, and as you keep going lower, then the emitter voltage is going to drop lower than 5 volts there, and more current is going to flow. Hopefully that makes sense. If we put this directly to ground, you can see we would have a direct path basically. It'd be through the resistor, so current would be limited, but all the current would go from base to ground. There'd be none for the emitter to collector, and therefore we got this resistor just to limit the current. We'll get the massive amount of current this way, even with the small trickle of current going that way. So, in any case, we drop lower. Another way you can think of it, sometimes you see PNP bipolar junction transistors when there's a positive and a negative voltage in relationship to ground. So, in relationship to ground, we can have a more negative voltage, and that might be easier to understand. You can see as we move farther away from ground there, the voltage difference builds up compared to ground. It gets more negative right there, and thus more current flow. Hopefully that makes sense. But the main thing is we set a voltage difference at the emitter, just like the NPN bipolar junction transistor, and the current flows. It's also going to flow through the LED because that's the path to ground. The LED is going to drop a certain amount of voltage, so a blue LED that we saw first will mean that ultimately we're limited to about 2 volts. That will build up across that resistor because the LED drops 3. Whereas a red LED drops about 2 volts, so we can get about 3 volts across the resistor. But blue LEDs are naturally brighter than red LEDs, so they light up more with the same amount of current. So we'll come back to the circuit and take a quick look. That's about it. I hope you enjoyed. Make sure you check out one of the other videos I posted to the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.